So we continue to study the covariant following the book of Carrol at around page 122. We end the derivative. It's not always necessary to the concept of well-defined tensor. In particular, the exterior derivatives as a vector field commutator are both well-defined under the pressure. Thus, if delta is a crossover connection, omega mu is manifold with a vector field, we can write what is the omega? Delta mu, omega mu, zero mu, omega mu equal. What is this? I'm confused. And xy mu. This is a Lie bracket delta prime mu y lambda delta lambda x mu equal x lambda delta lambda y mu y lambda delta lambda x mu. What is this? If the condition not torsion-free, the last suits are no longer true. The more fundamental definition of the communities are those in terms of partial derivative. That's right. Oh, the omega. So I think the differential exterior derivative omega is defined normal partial derivative and bracket with it is this means and partial derivatives where partial covariant derivative is a cross-factor connection. So if the connection is not torsion-free, the last quantity is not true. We are moving on. Let's review on the process by which we have adding a structure to our mathematical structure. Which is the basic notion which you are presumed to be familiar with. We introduce the concept of the open subset ourselves. This is equivalent to introduce a possible. Then by demanding that each open set look like region and that the coordinate charts be smoothly thrown together, the topological space became a manifold. A manifold is very flexible and can exist namely with a tangent vector that is the ability to take the derivative and so forth. We then proceed to put the metric on the family in manifold with metric sometimes individual of the metric. We found we could introduce a connection to take a correct. Once we have there is automatically unique torsion-free connection. Likewise, we could introduce the independent volume form. Also run its ultimate instrument with the measure impact. There is nothing to stop us from into the marathon or metric or a given manifold. In general, relativity, we do have a physical network with this form and the covariant derivative and okay, let's go to the section 3.3. Parallel transport and geodesic. Parallel transport sport and geodesic. Now we know how to take over derivative. Let's step back and put this into context differential margin. We think of derivative as a way of proving how fast something is getting. The crucial issue is changing with liquid run. An order fraction different number at this point is better. And it's straightforward to compare two different numbers. So we should be surprised that the partial derivative function remain varied. But tensor is mapped from vector and dual vector to real number. And it's not clear how to compare such map different points. Since we have such a concept equivalent derivative, can we think of it as some measuring the right to change tensor? The answer turns out to be yes. Therefore, the instant rate of change of tensor field in comparison to what tensor would be if it were. But transporting in other words an equation different space were keeping on the basis of which we compare nearby. It turns out that concept of parallel transport in its own right was sometimes thinking records that influence in unnecessarily careful about the fact vector element of the tangent space defined in individual probabilities blah 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 blah. But the difference in the words around keeping concept right is parallel transport. Parallel transport require friction to be red transport for vector from one point to independent path take with if it was no natural rate of unlike some of the where there is no solution to this, but large deliberate fractal vector can be run comparing. They are elements of the same tangent space. For example, So, I skip some English, some sentence. Enough about we can not do. Let's see what we can. Parallel transport is supposed to be the curved space generalization of the concept, keeping the vector constant as we along a path similar for a tensor orbit. Even a curved x mu requires the constant over tensor along this curve in front is simply the constant. D lambda t mu var mu dx mu d lambda x mu d mu goes there x mu lambda on x mu lambda curve x mu lambda. To make this probably tensorial, we simply replace this precedent by a current by direction derivative. これをsomething 方向directional derivative. This is mapped different area along the path from KL test. We use the dual transport to be record the current derivative. Parallel transport. Dx d lambda t equal to this is parallel transportation where we think of parallel transport tensor t along with the curve x lambda x sigma. Okay, t. This is a relative tensor equation known as the equation parallel transform for a vector it with the form d lambda v mu plus gamma mu rho sigma dx rho dx lambda rho. We can look at the parallel transport equation as a first order difference equation, defining initial by problem. Yeah. Given a tensor tensor, there will be a unique conjecture with tensor 2 as the plus such we say such tensor is parallel transport. The notion of parallel transport is omitted on the question, and the different question lead to the question is metric company. The metric is always parallel transport with d lambda z mu parallel transport. So metric compatible. Metric compatible. Yeah. If we assume Z is metric compatible, I think with me Z is invariant under parallel transport. Or the inner product of two parallel transport vector is preserved. That the v mu and v parallel transport we have. This means the parallel transport with respect to compatible connection pairs of the normal vector, the sensible squarity, and so on. Yeah. D lambda. D lambda means so. This is only parallel transport. So under parallel transport. Yeah. Sorry. ちょっとはい、もっとストップ。